So we're now going to proceed on and talk about some of the hardware overview. What are we doing? How do the products work? So again, I'm Vince Westin, Adnan Sahin, and we're going to talk through these pieces and carry on. As we do this, I'm going to lead some of the introductory sections, and Adnan's going to be driving our NVMe discussions and all as we get forward. So talking about the family, you had asked earlier, what are we positioning in the market? How are things selling? So our current most up-to-date versions of the VMAX are the 250 and the 950. We still offer the 450 and the 850. We still offer the hybrid boxes, but these are the current products. The 250 is designed as very small, simple, scalable. The one you saw out there, right? 2 bricks in half a rack. Able to deliver lots of IOPS, lots of capacity, 64 front-end ports, and you can scale a little. And again, as we go down market with this, because we have a number of customers interested in some of these resilience features, we're finding that we're selling about half of our product now as 250s, right? So both, well, from a petabytes and from a dollar revenue perspective, it's about half on 250s, right? And the other half is on the 950 mostly now. We flipped. There's a small percentage of other things still going on, but the 950 has given us a great boost. We've got now 18 cores per director and some of those kind of things. We'll talk through the hardware in a bit. So these are the two.
Are you saying that customers are focusing more on many more smaller boxes than they are on the mega boxes that they may have done in the past?
Well, so we have two types of customers who are buying these. Some of the folks who are buying these are buying because their whole implementation is smaller. They only want 50 or 100, 200 terabytes.
Well, I mean,
right?
Yeah, to say smaller and it's still a petabyte. What was it, 5 years ago? We were really impressed with a petabyte customer.
Yeah, but when you look at it, those two configurations are vastly diverse. 1 petabyte, 4 petabytes, 1 million, 6.7 million. So there's quite a diversion there.
Yes. So it depends. There are some folks who want the additional IOPS per gig kind of thing, right? If you look at, this is 4 times the capacity, but over 6 times the IOPS, right? So if you need much higher I/O density, you might decide you want the 950. The other thing that causes some people to think about how they want to do this is something that the Starbucks IT folks call the blast radius, right? How much data am I willing to put in one array? Because if a grenade went off and it was dead, right, what would be the blast radius to my applications? How much would I lose?
Yeah, I was wondering as much as to whether it was the fact that people are using different other types of storage and the fact that the growth is perhaps unstructured in other areas, and therefore there isn't necessarily a need to have the bigger high-end boxes as there might have been in the 20 years ago maybe.
We still have, I've got one customer that routinely buys 75 or so of these a quarter, right? We have customers who consume a lot of this stuff.
75 a quarter.
Yes. Put 2 of them in a rack and it only takes up 35 or so racks. Yeah.
Only.
We have other customers who
that proves that hyperscale all runs hyperconverged there, don't it?
We have other customers who are buying, 5+ petabytes a quarter, and when you're buying 5 petabytes a quarter, you may not want as many small boxes. You may not have the isolation. It depends on your app style, right? If you're building small applications that you can reasonably isolate, and so you can build pods of things, then a number of small boxes may help you keep your pod definitions and manage all of it that way. If you're building large applications that have half petabyte, or more of associated data that can't live without all of it, right? Buying one larger array and putting it all in there gives you a different way to manage it. So it really depends. Again, we're splitting our revenue about half and half, and it doesn't really matter how big the customer is, because again, I have customers who buy dozens or more of these frames every quarter. Luckily we have some who buy lots of 950s every quarter too. So it really depends. And then on the 250, we get a whole lot of customers who are buying 2 or 1. Right, but lately we've seen a lot of 2 with active in a metro type configuration, just because the availability you get out of that. For most companies, if they had 2, real data centers wiped out by some event, their whole company's gone anyway. Right, out of region doesn't make much sense to somebody who doesn't have any of their infrastructure outside of their region. So being able to do active in a couple of colos gives them a great opportunity to do that, and we can just drop these in, turn on RDF, go, right, and it makes it really easy for them to have that kind of configuration.
What's the story from an operations perspective? I remember when I had VMAX 2 back in 2012, 2013, there was quite a long provisioning time to stand up a VMAX.
Yep.
A week
So
to 2 weeks. Has that improved?
we worked very hard as we moved into VMAX 3 to simplify a lot of things. So we pre-configured the arrays. The drives are carved up. We'll talk about the drive layouts in a couple of slides.
Okay.
We carve all that up. It's pre-configured and ready to go. So when you turn on the box, you plug it in, you turn it on, you give access to the host on the front end ports. You start setting up LUNs and doing I/O. You can be doing I/O in 30 minutes or less. Right? It's designed to be dramatically easier than the things we used to do. We used to have limits on the size you could make of a device, right? Which was in the gigabytes range. You can now take a device, start it at megabytes, and online scale it to 64 terabytes or more if you want to. Not that I think that giant LUNs are really good because you can have some queuing challenges, but we do have some very large customers who parcel out as 60 terabyte LUNs over and over again, because when you're managing 950s with multiple petabytes of capacity in them, managing small LUNs will drive you crazy. Right? So, it all depends on the scale of your operations and what you're trying to get done, but we've definitely...
Isn't this why we automate things?
Excuse me?
Isn't this why we automate things?
So yes. So the REST APIs and all, being able to automate all that is good. Also, as we talk about snaps, we'll talk about how we automate that, because if you build, I've got one customer that's running 2 million snaps in each array on multiple arrays. If you actually had to actively manage 2 million snaps, right, you'd last about a week. You'd pull your hair out, you'd go home and check into the insane asylum. We figured out some ways to manage some of that. So we've tried to take a lot of the complexity that used to be there and make it all more virtual, real-time, easy to do, right? There's one big pool of storage. You create LUNs, they sit in the pool. The array manages all that, done. All right, so no micromanagement of various things. Someone's got a phone. All right.
Speaking about automation and so on, are you guys setting up a message about infra as a code, this kind of thing, composable storage? Like HP has been talking about a lot about composable infrastructures and so on, right?
So we make it easy if you wanted to use VBlocks, right, to be able to increment that with VMAX and all the other components and make it easy to mix and match pieces. The storage, the foundations within the array are locked, right? We don't dynamically do a lot of stuff. We're not currently adding applications externally into the array. We do offer the ability to embed NAS in the box. We do offer the ability to embed all the management tools. We've done some other things.
So did you guys have a Cinder driver, things like that?
We've got the Cinder driver. Right, you can pick that up. We've got the REST API, so you can use us as a part of that infrastructure, but we're not trying to change the nature of the internals. We're making it easier to manage externally.
Okay.
But yes, we understand that you need to be able to automate all of that. You need the REST API hooks. You need the Cinder drivers. You need those other things to be able to do this. We're trying to get all of our customers away from scripts and moving all into REST API management and those kinds of things. We've got XML outputs. If you're running the command line, right, you can do XML outputs of all that and put it into automation as well. So you're not doing scraping of fixed delimited fields.
When you say you're helping customers, do you have some kind of services you're offering to the customers that they can talk with your development team and you can help them to kind of rewrite all this thing in APIs?
Yeah, we've got a services team. We've actually got an EMC code group that's public that we share a lot of the ideas of, hey, if you want to do this kind of thing with your array, here's how you do it. Examples of lots of different management pieces of reusable code. Here, take it, have fun. As well as professional services if you want us to take your specific scripts and work to migrate them into that kind of an environment. Absolutely.
Looking at the slide you had before, you had a kind of differentiation on the 950F. If I want to plug my VMAX with a Z series mainframe, do I have to go for the 950F because I'm looking the ports are kind of different?
We do not have FICON support on the 250.
Yeah.
Right.
Okay. Cool. Thanks.
Yep.
Okay.
So in terms of the architecture, as we moved from the older VMAXs into the VMAX 3 world, we decided that we were going to, instead of having cores or threads dedicated to ports, we pooled our resources. So originally, the CPUs were dedicated to ports because the hardware was laid out that way, right? You had literally ports plugged into the core, and that's the way it worked. And you could, at one point on some of the DMXs, you could take a razor blade and scratch across the middle of the boards between the logical directors and not hit any traces. Right, they were separate, isolated directors. Now that's all software, and so we have multiple cores running front-end code, multiple running back-end code, multiple running the infrastructure management, the EDS pieces, which is the engineering data services. We do all of that in separate pieces, in part for isolation. We don't physically isolate them on CPUs. We can move threads back and forth between these various services on the fly. But we do this because if there's a fault somewhere, for example, if you somehow had a front end where the entire block of code running front end went sideways, right, you can reboot that front end without touching any of the other pieces, back end access or anything else. Right? Same kind of thing on the other directors. If you lose this piece of back end, I can fail those services over to a partner and reboot this and bring it all back up. The array doesn't take any issue with that. And so by being able to do this in compartments, it allows us to isolate challenges that do come up, because we always endeavor to write perfect code, but we never succeed. Right? There's always going to be something. And so by doing isolation, we can do a better job of managing faults and making sure that we maintain the resilience that we're looking for. So this has allowed us to scale up the front end ports, allowed us to scale up the back end ports, be able to easily manage where things are connected, and give the customers the flexibility of where this is going to go. Right? And as you embed NAS on the front end, we can drop NAS in here, put some ports on some CPU cores threads on NAS, right, and start serving up various NAS protocols and all that kind of thing as well. Right? iSCSI, FICON, whatever you want to do, each managed as a separate logical set.
So the pools are balanced dynamically?
They're currently balanced in a fairly static. We can move some of the threads will move a bit, but it's fairly static. As we do more and more code, we're making that more and more dynamic, so we're moving more threads real time based on where the workloads are. That's one of those things that's somewhat tricky to manage. You want to make the array as effective as possible without doing any automation that might lead you down a crazy path.
Yeah.
Go back one slide, please. Just
Absolutely.
So on the NAS perspective, if it's running in the front end, right? You're running, I guess, like a virtualized process was your eNAS, I guess, right?
Right.
The domain for that NAS, if that is, I guess, for an address space that is serving as an NFS or SMB or whatever.
Right.
It's doing, the domain for that is within that frame, within the two controllers of that VMAX?
So the way we implement eNAS, if you know about the Solera code or VNX NAS, right, it's the same kind of thing. So we load the code in here. This has a logical data mover, can have multiple virtual data movers, and they each have an address space. But the way that particular code works, it doesn't share its data with any other.
Okay.
So it lives on one director, but it has an ability to fail over to a partner on a different director. Right, so we'd have like a 3+1 active, 3 active, and a standby kind of logical data mover configuration. Okay. So in the event that something goes wrong here, again, if I need to reboot this, I simply pass all the I/O over to the other. It picks up all the IP addresses, everything keeps running, and then we can just fail it back. You do the same kind of thing for upgrades of the NAS code.
All right, so you guys are you guys looking at making like from a NAS perspective, if I keep on putting frames, like your customer buys 75 cents a quarter or whatever it is, to be able to just add on and have a NAS that scales out that way in that, are you guys looking at doing that?
So we're looking at file system options. As we've become part of Dell, we had ideas of where we were going to go, and then we became part of Dell, and that's kind of changed a few things. So as we're part of Dell, we're looking at what do we do for file system across all of this. We would love to have a file system that would do scale out. So not only could we lay it out across multiple directors in the array, but with Metro could lay it out across multiple arrays, right, with a single file system.
You own a platform that does that a little bit, right?
So yes, we do. Unfortunately, the way their file system,
that's true.
The way the file system is designed in that it doesn't it's not easy to flip that into a new block back end. Right, they already have all the RAID, they have everything else. It's hooked deep in that code, and so while Isilon has options for that, right, there are other things we can do. So we have a strategy on that for where we're going to go with it. It's just going to take a little while to make that happen.
Okay, thanks.
Yep.
Since you're talking about scale out and so on, you guys just did the Elastifile thing, right? Is that going to go into the VMAX?
We just did which?
Elastifile. You guys did a partnership with Elastifile, right?
So again, we're looking at where our next file system will be.
Okay.
And I'll leave it at that.
There. File system for VMAX.
So we do have some customers who buy VMAX systems and set up different file systems on servers where it's an OCFS or whatever file system they choose, and use the fact that the LUNs are active and scale it across, even with Metro, across data centers, right? So there are some folks who are doing that now. There are multiple file system options. Our eNAS is one option that we embed in the array. That doesn't mean it has to be your choice. It's not the perfect solution for everyone, and that's part of why we have standard interfaces, and you can go do all those kinds of things.
eNAS is an extra cost option, right?
ENAS is extra cost on the F. It's included in FX. So you just have to pick different front-end cards when you're buying the box for the FX, because the FX includes pretty much every possible option you could ever want. Right? It includes all the options of RDF. It includes ENAS. It includes everything.
And ENAS penetration is
About 20% of our open frames.
little bit higher than I thought.
So yeah, it's higher than I originally thought too. But again, especially as we're doing a lot of the smaller boxes, a lot of these customers are like, well, I only have 100 terabytes. If I put ENAS in there, I don't have to buy anything else.
Yeah,
right?
kind of
One thing to manage.
Unified, one box.
Right, the whole unified theory.
Everything's there. Yeah.
And especially as you go down market, that becomes much more valuable.
Oh, no, then you end up with the customers who point at the array and go, and that's our SAN.
Right. We also have some customers, for example, I had a doctor's group where they had an Oracle database that managed everything that was coming in, but all of the dictation was done into files that sat on a file system. Well, when they replicated that, they needed to be absolutely sure that the database and the file system were in sync, right? We cannot ever fail over and have entries in the database that aren't in the file system, or dictations in the file system that can't. You need to lose the exact same data at all times, right? Because you're doing async replication, you will lose something.
I'm sure that's not how they worded it. But
Not exactly, but close enough. And so with the async replication, because you're doing it in a single unified box, you get a unified result in the target. So in terms of scale, we start off with, if you buy a single brick system, you've got the pair of directors, all the cache and all that is set up across the memory in those two. As you expand out, right, we can online add a fabric and add a second brick with a second set of directors, and all the metadata just extends out to the cache on those, and you can keep going all the way out to 8 bricks right on the 950. And all of the metadata becomes spread across everything. And so you have the option to start small and grow, and we don't lock down where things live. Now, as we do this, you'll add the new brick. The new brick will have new capacity. Once you turn the new capacity on, the array will say, I'm going to go pick up a chunk of the data and try to equalize the utilization of all the drives so they all become equally full, which is the same whether you're spreading additional drives within a given brick or adding additional bricks. The functionality works the same. The data just gets respread across the box.
So when you said you're spreading the metadata, are you replicating it more than once? Are you
So there are a
updating
few
it
key
with-
pieces of metadata that we keep 3 copies of. And those will be distributed across cache. Other than that, we keep 2 copies of pretty much everything. And all of the data, all the host data is all mirrored in cache at all times. Well, excuse me, the writes are mirrored, the reads have a mirror slot available. So if you write to them, you don't have to go find a new slot.
So an IO that comes in, a write IO that comes in, generates a replica across 2 nodes.
Yes. Yeah, and I've actually got an IO diagram coming up in a couple slides to talk through exactly how we do that.
and back-end media is attached to 2 bricks?
Backend media is attached to each brick.
To each brick.
Right, you've got redundant connections from the 2 directors going down to the media.
Okay.
But you've got data spread across the box.
Right.
We don't have, brick failures are not a problem that is happening.
Well, they're not. Yeah, we're
Right.
in the not very frequent, but
Right.
you're in the not very frequent business.
Right. So, we won't say that there's any product in the world that has more than a very limited number of installs that has no outages, right? There are issues that happen. So the trick is, how do you make sure that you limit the number, that you limit the duration, and that you make it data unavailability and not data loss, right? Those are the tricks. So
And you might want to think about scope too, and have part.
certainly scope, yeah. And we'll talk about some of the other things we do with RDF to actually help with that too, because you could lose an entire set of components here on drives and read the data remotely off RDF while you get those DAs back online.
Yeah. Well, of course.
Right. So lots of options for how you want to manage availability.
Can I confirm someone that's newer to VMAX? So you got a pair of bricks, bricks with a pair of directors. You can then add disks onto the back of that if you want to scale up, or if you want to scale out, you can then add another brick depending on the system. Cool.
Yeah. So it scales drives behind the bricks and then bricks across. And in terms of performance scaling, right? We had some folks from Gartner, as Mr. Fawcett made the joke, who actually said, well, show us something about your scale. So we said, okay, we'll take a baseline, we'll draw a green line here that says, this is 2, this is 4, this is 6, this is 8, right? And then we'll draw the performance for read misses, because who really cares about all the hits, right? If these are 2, right, then where do I scale? And pretty much the 4 is right about sitting around the 4, and the 8 bricks is sitting right around the 8 bricks, both for 8K backend IOs and 128K large block backend IOs, right? So the scale of this is fairly linear, right? And you can just add brick after brick after brick and keep going. So again, we've been doing this for quite a while. That's not to say that if you had a single director doing things, you couldn't do things faster than what any one director effectively gets in this. There is some cost to the overhead of having to talk between the many devices, but if you only have 1 or 2, you can't scale it like this, right? So we can do much larger workloads because of the fact that we can scale.
What are some of the use cases that are not a good fit for VMAX or Flash?
Well, currently, again, if you walked in and said, I've got a ton of VDI, it dedupes really well, it compresses really well, and that's all I want to do with this box, right, is I've got my virtual infrastructure, I would say, gee, you should probably look at Extreme because it can probably do a more cost-effective solution for that problem, right? So it really depends. I mean, we've got Extreme IO, we've got also Isilon, we've got Unity, we've got SC, we've got a plethora of products because our customers have a wide variety of challenges that they want to solve.
What about apps that are mission critical, business critical? Are there any particular types that when you hear about them as a use case that this is not a fit?
No, VMAX originally was doing better with small block, and we didn't have the big pipes to do all the bandwidth. When we built VMAX 3, we really ripped open the pipes and made sure that we could do large block I/O. So if you go look at the SPC2 numbers that we put out for this, it's monstrous numbers, right? We're sustaining 80 gigs a second of throughput, and the thing's a monster.
What are some of the things when you look at your current architecture that you're trying to improve or you realize that are pain points or risky that you're trying to fix in engineering?
Well, Adnan's going to talk about where we see things going with NVMe. So you can have some of that discussion there. We don't discuss a lot of NDA stuff in a public forum like this, so there are limits to what I can talk about on that. But there are changes coming in the technology that get you access to more CPU cores, that get you access to more cache, that get you access to things that are lower latency like storage class memory. All of those kinds of things are going on, and so we're looking very carefully at the architecture to make sure that where we're going is going to be well suited to all the new technologies that are becoming available, so that we can take best advantage of those and make them available to customers.
Actually, to that point, let me ask a question on that. So as NVMe is coming out, obviously latency is king in that world, and so we've talked to a few vendors over the last couple of years about this, and they started to measure and talk about what their data path, their software data path, the latency in nanoseconds typically, how much they're adding to the latency from media up to presentation. How far do you measure that, and do you talk about that?
So we do things to measure it. We don't really talk about it.
Okay.
But it is, we're looking at how many, especially you start talking about things like the NVMe NAND and then the storage class memory and other things. Talking in milliseconds is pretty meaningless, right?
Yeah.
You're into microseconds or nanosecond discussions. And so, Adnan's going to talk about a good bit of that as we talk in the NVMe stuff at the end of the deck.
And you guys are working with Intel with the SPDK guys, right, too, on that?
Yeah. We are working with Intel and several other vendors on storage class memory to be able to augment the storage in the array so that you can have that very low latency stuff along with other. Part of the challenge that we're having fun working with on this is if you start buying drives that have latency times in the 10, 20, 30 microsecond range, right? What does that mean when you start doing things like compression where your hardware uncompressed of a track is 50 mics, right?
Everything's got a cost, yeah.
Right, so now do I compress the data that I put on that very expensive media? Because currently the forecast has been 5 to 10x the price of NAND.
Well, if you're buying a VMAX, I guess you're not as sensitive to cost as some of the other guys, right?
You're certainly
You're
not
sensitive to relative cost.
Right.
Absolute cost, sure thing.
Right, but the relative still is relatively expensive, right? So you have to, in current numbers, you'd have to get a lot of value out of that, right? So if you're on a trading floor, that might well be easily worth it, right? If you're running a website where your average customer is multiple milliseconds away, plus or minus half a millisecond on an I/O may not mean anything to your business, right? And so until that cost gets closer, Now, there has also been some interesting things going on over the last couple weeks where some of the early drives on storage class memory are coming out and the pricing is coming closer than 5x. It may be more like 3x, right? Which may mean a faster switch of customers onto that technology. And so again, as we look at how we're going to position that, again, Ed and I'll talk more about NVMe stuff.
Just on that slide. So, do you have any customers that are asking for more than 8 vBricks? Is that a requirement that you're trying to meet in the future?
So we've had customers ask for it. The larger you scale, the more complexity you have.
Right.
You know, as you scale up from 64,000 LUNs, you know, we now have support in the software for 1 million LUNs. Well, but that went over the 16 bits. You're now 24-bit addressing for LUNs. And all of our customers have lots of infrastructure, and they know that the LUN's a 16-bit address. They happen to be wrong now, but they know it, right? And so we've had that ability since we came out with the VMAX 3 over 3 years ago. We aren't using it yet for host front-end devices because we're still waiting for our customers to move everything over to new software that understands that it's not all 16 bits. Because the last thing we want is somebody to do I/O to 2 different LUNs thinking they're the same because they rounded off the upper bits, right? That would be bad.
Okay, but in special cases like vVols where you're using
Right, so vVols allows us.
LUNs, you support more than 64K, right?
Right, we do 64K today with vVols.
Oh, it's still 64K with
Yeah.
vVol.
But we have the architecture goes. If you look at the LUN addresses for some of our internal devices, those are up in the millions, right? So we support lots of LUNs. We just haven't yet opened that up on the front end again because of a lot of the management tools that our customers have, where they know that 16 bits is how it does things. And we're still working a few things with VMware to make
I would
sure
still argue that you open it up for vVols via subordinate LUNs and avoid that problem. You can avoid that problem because 64,000 VMDKs on a 6 petabyte device is going to be easy to hit.
Yeah. Yeah. So again, it's a software tweak, right? We change it in software.
Yeah.
Currently, our vVol implementation count is low. So as
everybody's vVol implementation count is relatively low, and the people who are most likely to be running vVols are also the people who would like the new shiny architecture as opposed to the old stable architecture. And so, yeah.
So again, we're having the discussion, and it's where do you put your engineering efforts, right? And your qual efforts and all that stuff.
Oh, yeah,
so it's there, and we can do it. It hasn't
on the
become a
roadmap,
priority.
and exactly where on the roadmap it is depends on which customers yell for it.
Exactly.
So the answer at the moment is 8 is where you're staying.
Right, and we don't plan to increase above 8 in
Because
the
it
next
increases operational
couple of
complexity,
generations.
operational
Yeah, just
risk.
because of
Right.
and also, you know, the more pieces you have, the more risk there is on service and everything else, right? If I've got 48 bricks in there and I go and muck one up, I've now mucked up a 48 brick system, right? We don't have a lot of customers saying, gee, I really wish I could put 25 petabytes in one frame, right? Again, the blast radius on that just gets really big. So in general, 8 has been enough to meet what most customers are comfortable buying. They aren't saying they'd really like more. We've had the engineering discussions. We're not doing it yet.
And 8 vBricks fits into how many racks? Is that a single?
Currently, that's a 4-rack 950. We're working on things to smush.
Right.
Put it in the compressor and smash it down.
EMC smushes storage.
Yeah, that's the good idea.
Yeah.
So, Vince, will you discuss federation between boxes? Because that federation between boxes, in some respects, eliminates some of that need to build one enormous box.
Right, the non-disruptive mobility, being able to pick things up, as well as with RDF, being able to coordinate across them. Yes.
Are you talking about that?
Yep.
Yeah, good. Okay.
Absolutely. Yeah, because that is part of the key value proposition, right? All right, in terms of the hardware, I'm not going to spend a lot of time drilling into the hardware pieces. If you want to, I brought every hardware slide. I can show you how the power is connected and all those things if you really want it, because I know that this audience gets rather technical and sometimes you want that stuff.
Geek out.
So if you want all that, I can do it, but in the interest of time, we thought we'd start with this. So in general, the system can have multiple bricks. Each brick is a dual director engine. So this is how the engines look from the back end cable side. The front side is not very interesting because it's just fans, right? You pull those out of the way to get to the directors. And then, so your CPU, your cache, all the host access ports, all those things are there, as well as the connections to the drives. Then we have DAEs, right, that hold the actual media. and then we have standby power supply. So in the event that we lose one leg of power, we keep right on running, we keep caching data, we keep doing all those things. The cache in the array is just DIMMs, right? It is not a non-volatile store. If it was a non-volatile store, we would have to encrypt it, right? Because data at rest encryption. It's just standard DIMMs, but we have the batteries here that power the box. So if we lose both A and B power, the batteries hold the directors up, and we vault all the memory onto NVMe slicks that are sitting in the back of the director. Right, so we don't keep the drive DAEs powered. We just keep the directors powered, but they can vault onto non-volatile storage, and then we can shut down cleanly. That way, also, we're not dealing with battery problems, because you all may remember the power outage that happened in the Northeast a few years ago. That in many data centers they were out of power for up to 72 hours or so.
And what's the battery life of the battery? What's the battery life? How long they can sustain a failure, failure?
Oh no! If you lose A and B power feeds, we stop front-end I/O, we destage to this, and we shut down. It's 30 seconds. The batteries can do 5 minutes, but we don't keep the array live.
Okay.
We're just because they're batteries.
So
Yeah, they're real lithium ion. You can't ship them by air fully charged batteries. We have challenges, right? Customers have a choice. We can either ship them to you by air, in which case they have to be 30% charged and they'll charge in your data center, or we can ship them by ground fully charged, right? But the FAA will not allow us to ship. These things are big, right?
The truck blows up right now.
Yeah. But that's why you keep them locally stocked, and you have other things. But you just run the batteries 30% and you charge them when they get there. So
yeah, I mean, basically, instead of doing the power fail detect dump to flash in the DIMM, you've centralized it.
Right. And it allows us to make sure that we can manage things. We can also have it be resilient. So within the box, we can make multiple copies striped across the internal flash, so that if I lose a director and a flash and I'm coming up, I still have copies of all that wonderful metadata, right? Because without the metadata in any modern array, right, if the metadata is gone, the data is gone.
Oh yeah.
Right? So we've got to be very paranoid about how we back all that stuff up.
Right. Flash made all this so much easier.
Oh, absolutely.
Batteries directly supporting DRAM was such a disaster.
Yeah. Yeah. The only problem.
Did you ask a question from the Twitter feed?
No, not yet. I thought it might be coming.
Yeah, the only challenge, of course, is the bandwidth you need to be able to dump all that memory into those slicks in time to let the battery shut down, right? So
right, which is why almost everybody else does it in NVDIMMs, because then you distribute that bandwidth.
Right, but when you do it in NVDIMMs, you now have to encrypt all the data going to the DIMM in order to have proper DARE support, because your data is on that DIMM.
Just don't tell anybody you're not encrypting.
One would hope. I do not believe the vast majority of other people do that, but that's a whole nother story.
Yeah, that's a separate, DARE discussion.
Yeah.
But that's why we do it that way, right? Because we use the same encryption module to encrypt the data that's going to these as we use to go into the other drives, and so it's all consistent. We have one key per drive and all that wonderful stuff.
All right, and it's encrypt on power fail.
Yes, even the Power Vault stuff is all encrypted as well.
Yeah.
Yes. So, but yeah, we run with the cache unencrypted because we didn't want that overhead.
Oh
in
yeah,
real time.
Yeah.
At memory bandwidth, that gets expensive.
Yes.
To encrypt in real time.
Yeah.
You're either eating up a lot of CPU or you're putting a lot of hardware in, and we didn't want to do either one.
It is problematical.
Right. And as we discussed, as you do multiple bricks, we have a virtual matrix. On the 250, we actually cheat. On the 250, we just connect the matrix back to the other director in the other brick, right? Because there's only two. And so I can cross-connect here, and I can use the PCIe cross-memory interconnects between the directors in the same engine. So that's all I need. But since the 950 goes bigger, we've got these 18-port InfiniBand switches that scale the switch out. And then Ethernet to allow all the things to talk nicely. Again, on the 250, we just cross-connect a whole bunch of Ethernet wires in fun ways between the little management modules you can see here. And then in the larger box, we have Ethernet switches that cross-connect everything.
So if you have several 250s, each of those act as a single pod, or can you interconnect them between each other?
So the 250 with 2 bricks act as a single array. If you put 4 bricks in a frame, they're 2 separate arrays. They don't even know about each other.
Okay.
They're completely isolated. Because you can't make all those connections work without the virtual matrix, at which point you're buying the 950.
Yeah.
Right.
So
So
what is the smallest configuration I can buy?
you can buy a single brick with, on the 250, you can buy a single brick with 13 terabytes of usable flash.
Okay.
Right. That's a pretty small box.
Yep.
And then you can scale that up to a petabyte and the dual bricks. And then on the 950, on the open side, we do a minimum of 50 terabytes per brick. And part of the reason we do that is if you look at the cost of the brick versus the cost of the flash, it's not really worth buying 10 terabyte bricks. So
How about an upgrade process from a 250 to 950? Yeah.
yeah, we have a very nice forklift operation. We can drop the 950 next to it. We do non-disruptive migration, and we'll talk about that. So we can do it without taking the data offline, and then we take the old box.
Professional services guys would be glad to come to.
No.
The chassis are
No,
Okay.
Right.
no, it's a forklift. So
Well, it's a hand truck. The things have gotten smaller.
special hand truck. Yeah, okay. All right, so drilling into a little more to the engine. Again, like I said, on the front side, all you see is fans, but if you pull the fan block off, you can get to the director. The directors are serviced out the front of the array. I don't know if you all pulled them out there, but if you slide the director out, you don't change any of the cables, you don't mess with any of the slicks on the back end. So the nice thing is, if you have to replace a director, you power it off, you pull it out, you drop the new one in, you plug it back, put the fans back on, and you're done. You don't mess with all the cables. No cables are touched to remove a director. Right? And then if you need to replace a slick, you do individual slicks. So there's a mid-plane in between, makes all that fairly manageable. The power, as you can see here, there's 2 power supplies. There's actually 4 power supplies here, 2 for each. So you have A and B power going separately to 2 power supplies that power the director. There's no shared power between these directors, right? They each get A and B power feeds. Yeah, there's no power in the backplane. These are actually very simple pass-through cables, so the power plugs stay on the back. So you don't have to run any cables on the front of the system. But it gave us a way to make sure that, gee, if I have, one power supply A fail and one power supply B fail and something else fail, none of that will take out both directors, right? We're rather paranoid about how we keep the directors up. And then on the back end, again, you've got a management unit, you've got flash drives, you've got front-end host connections, you've got the fiber, the InfiniBand interconnect matrix between the bricks.
To go back to his question really quick, since you can't upgrade to 250 without a forklift, what's the smallest 950 configuration you can do?
You already said it.
Single brick of 50 terabytes.
50?
Yeah, 50. So that's the basic on this. Again, we got a bunch of PCIe slots here that we stick things in, and that's where our vault flash lives in these as part of, we stick in more vault depending on how much cache you put in the directors. Hardware specs for the individual components. The real differences here are the number of cores and the speed. Not a lot of speed difference. Our Intel chips are kept, we have high fans running on them, so we keep them cool so they all run in turbo mode from Intel, right? So you'll get an effective CPU rate higher than what's shown here, unless you're doing swamp cooling and running your data center at 90 degrees, at which point they will slow down a bit, right? So if you're doing swamp cooling, don't do that in Arizona. Right, it gets too hot.
Well, actually, it works really well in Arizona because
It's very cool at night. The problem is when it's 110 degrees during the day.
yeah, but evaporative cooling still works really well because it's 10% humidity.
It will evaporate. That's for sure.
It's interesting, the 250 has more dense port capability.
Yeah, so currently the 250 does 32 front-end ports. There's some configuration reasons internal to the brick why we do 24 on the 950.
Well, you
and
need to use some of the PCIe slots for the InfiniBand.
Yeah.
it's this has the same InfiniBand in it. It's actually we have certain configurations on the 950 where we use 4 flash slicks internally, and so we don't have room. This guy only uses 3 at most. So
And Slick is Dell EMC for
yeah, it's just the
card?
PCIe card we put in the slot.
Okay,
Yeah,
just I thought I got that, but
yeah. Yeah, so it's the interface cards.
Years you adopt the language.
Yes, the interface cards that we drop into each of those slots. And so because we have the ability to do 4 of the NVMe bricks or NVMe slicks in the chassis, we can't guarantee room for 4 front-end cards, so you get 3 there. As we do future generations, we may adjust that.